Okay, 5.7, we're going to graph inequality quadratics. Graphing an inequality quadratic is extremely similar to graphing an inequality line. Just like with a line, you have to have points in order to connect them and shade. Same thing with the quadratics. The thing is those points that you need to have are the vertex, the zeros, and the y-intercept. You can find them by hand, but by this time, you should be able to use your calculator pretty quickly and efficiently. You've already been tested on and have other questions regarding being able to do it by hand. So when it comes to doing this with the graphing, I'd probably use the calculator, vertex for your minimum or maximum, your x-intercepts, and your table for your y-intercept. When we have our vertex, zeros, and y-intercept, we need to make sure we put it on a labeled axis, as always, with arrows, x, y. Scale is 1. So we plot those critical points, the vertex, the zeros, and the y-intercepts. And then we need to connect those critical points. And we always connect our critical points when we're doing inequalities by either an open line or a closed line, dashed or solid, based on the symbol that is given. So if it's less or greater, we have a dashed line. And if we have less, equal, greater, equal, we have a closed line. The exact same rules that were applied to when we had linear inequalities. And just like linear inequalities, we had to shade either above or below the line. We have to shade above or below the vertex. All right, if we are greater or greater equal, from the vertex we shade up. If we are less or less equal, we shade from the vertex down. And that will be either inside or outside of the parabola, depends on which way it opens. But all we need to do is look at the vertex and our symbol, and that's how we're going to shade. So we're going to look at a few examples here. We're going to start with y greater than or equal to x squared minus 4x plus 3. I would, again, I would put it all in my calculator. Here's my calculator. Here's my equation, my graph. I would find all of those critical points. So when I'm having to graph this, I can find that y-intercept was at 3. I can do my calculate zeros, and I can find my x-intercepts are at 1 and 3, and then I can do my calculate, and in this case it's a minimum where I do left bound, I do right bound, and I find that it's at 2, -1. Again, I'm not going to go through this calculator stuff. You've been hopefully doing it long enough and well enough that you should be able to find minimums, maximums, x-intercepts, y-intercepts at this point. So now we need to connect our dots. Our dots are connected with a solid because it's equal to. Make sure we have arrows. Again, our axes, make sure they have arrows, make sure they have labels. And then I put my pencil on the vertex. And because my graph says greater, I shade above. And if I shade above, I'm inside of my parabola. So I just want to color that in and make sure that I'm clear that that's where the solutions are. They're going to be inside. All right, here I have y is less than negative x squared minus x plus 3. I would go to my calculator, put it in, and find all of the necessary pieces. So in this case, here, I'm going to find whatever that x-intercept, whatever that vertex. I'm sorry, the y-intercept, the vertex, and the x-intercepts. I'm going to find what those are, and then I'm going to connect them with dashed lines because it's not equal to. Okay. Then on the vertex here, I'm going to put my pencil, and this says I'm going to be less. Less means below. So when I shade below, I happen to be inside of my parabola. All right, let's try it again. Y less than x squared minus 9. If you put it into your calculator and graph it, here's our picture. Oops, here, y-intercept, vertex, x-intercepts, and again, dashed. Arrows, labels. Here's my vertex, and less means below, so I'm below my vertex, which means in this case, I'm outside of my parabola. So, and that's all it takes for graphing inequality quadratics.